Hi everyone, today's objectives is adding and subtracting rational expressions with the different denominators. So to start that, the procedure to find lowest common denominator, which is LCD, is to find the LCD of two or more rational expressions. 1. Find the prime fractions of each denominator. 2. Write a product that contains each unique prime factor, the greatest number of times that factor occur in any prime fraction. Or, if you prefer to use exponents, write the product that contains each unique prime factor raised to the greatest exponent that occurs on that factor in any prime fraction. Number 3, simplify the product found in step 2. It sounds really wordy, but it sounds really confusing and you have no idea what they are saying. So let me demonstrate for you, but you should know what is a prime fraction. We talked about that already. That's when you break it down into the very basic 2, 3. Those are prime fraction that you did for chapter 6 and chapter 7. This is what we're going to do today, and then we're going to try to find the ones that's in a fraction, like what we did last section. All of them same. Now what happens if it's not the same? Very basic, just a quick reminder from elementary school. If you have a fraction that's 1 over 8 and 7 over 12, your teacher will always say, hey, find the common denominator. So find the common denominator is really what we are trying to do here. Now you can just say, oh, I can do the factor tree and then multiply the number. There's also another little way that I would like to show you. So just like what we did before, if you have 8 and 12, and then if you do this, draw your L like what we did, because that's how we find the common denominator. Now, common denominator is a little bit different than lowest common denominator. Let me show you. So we're going to process still the same. So 8 and 12 you both have. You can start with 2. There's a 4. So we'll start with 4. And if you pull out 4, they have 2 and 3 in common. Now, for the greatest common multiple, which is you would do just the side. But when you have lowest common denominator, that means in the denominator, that means the bottom. So what we're going to do is now we're going to do 4 on the side times 2 times 3. So what we are going to do now is we are going to take this one times this one times this one. And if you take all the outside, multiply them together, it's going to be your lowest common denominator. And then before, we are only multiplying the sides. That is your greatest common factor. Greatest common factor means what they both have in common. And then lowest common denominator means what is the smallest number both can divide into it. In this case, when you work out that problem, 4 times 2, which is 8, 8 times 3 is 24. And therefore, 24 will be your lowest common denominator. Now, if you look at lowest common denominator is 24, you are going to multiply by 3 to get 24 here. Multiply by 3, that's going to give you 24. Because when you have to multiply something in the denominator, you have to multiply something in the numerator to make it equivalent fractions. That's what they want you to do. Then 12 goes into 24 2 times. And the new fraction you're going to have is 3 over 24 and comma 14 over 24. And that's all you have to do for me day 1. Now, if you think about this, it's really interesting. If you want to think that, hey, if I have 12, I can multiply by 2. If I have 8, I can multiply by 3. That's exactly what you have to do. So in this case, if you want to think about it, you can just look at 8 is times 3. 8 needs 3 to make it 24. And then 12 needs the 2 to make it 24. So it's just crisscross what they need. What is the missing piece you want to multiply? Going on to example number 2. Example number 2 is the same thing if you want to choose to do that. So that's going to be 4x squared and then 6x to the third. And if you do the L thing, you can say I can take out 2. That give me 2x squared. I can take out 2. That's 3x squared. And I can also still take out 8. I can still take out x squared, and that's going to give me 2, and this is going to be 3x. So lowest common denominator is going to be 2 times x squared times 2 times 3x. Or if you want to write it in parentheses, which is I prefer, please do not use just an x because your x all look the same. So you can write down 2 times x squared times 2 times 3x. And then when you multiply together, that's 12x to the third. And really, again, if you are looking at 4x, you need to multiply a 3x. If you're looking at 6x squared, you need to multiply a 2. So let's double check. How do I make 4x squared into 12x to the third? Well, seriously, you do multiply a 3x. Look, that's exactly what you need, all right? So look at the green arrow. So you're going to multiply 3x. And then if you have 6x to the third, you multiply a 2. That's also give you 2x to the third. And then when you do that, that's going to be 9x over 12x to the third. And the next fraction is 10 times 12x to the third. Please try example number 3 and 4. Just want you to double check. I put all the process down. For number 3, lowest common denominator is 36x to the fifth. And you can see it again. It's exactly what I talk about. All the missing pieces, you can get it from the process, from the work you see. And you just have to multiply the top to get the 3y. When you have 12x to the fifth, you're missing a 3. So you multiply 3 on top and bottom, and you can actually get that 3 from here. And then same thing with the other one. You're missing the 4x to the third. And then make sure you multiply the top. Same thing with, so it's 3y over 36x to the fifth. And the other one is 20 times x to the third over 36x to the fifth. Example number 4 is 3mp over 30mn squared and 14m over 30mn squared. Those are equivalent fraction to the ones that's giving it to you. That is with a denominator with a monomial, which is one term. So now we are moving on to the two terms denominator. So when you're looking at two term denominators, you need to remember this starts to look like factoring again. And it is. So we are going to take that and then factor 7 over 5 times minus 3. And you pull out a 5. And you also have 5 over 2 times minus 3. If you want me to show you the long way, it's totally okay. Find what is the best way to make their denominator is exactly the same. For anything that's missing, you gotta make sure you multiply something. So if you want to see the longhand, and hopefully eventually you don't need this, you have a 5x minus 3, and then you have a 2 and x minus 3. Now let's draw the L, and I want you guys to take a look. What is the one they have in common? Oh, the one they have in common is really x minus 3. And then you left with a 5, and you left with a 2. And the reason I can do that is because that's a 5 times. That's 2 times. It's always multiplication. Lowest common denominator is really x minus 3 times 5 times 2. And that's going to be 10 times x minus 3. That's your denominator. And is the other things what you are missing that you need to multiply works the same way? Yes. So if you think about this, this is going to be 5. Let me rewrite it again. That's 7 over 5 times x minus 3 and 5 over 2 times x minus 3. So if you look at it, for the 7 over 5 times x minus 3, it's missing multiplying by a 2. If I multiply by a 2, I get the 10x minus 3. And then I'm going to multiply the top by 2. The bottom for the 5 over 2x minus 3 is missing a 5 to make it 10. What you have right here is literally 14 times 10 over x minus 3 and 25 over 10 times x minus 3. Factoring out, find what is the piece that's missing that's not shared by both of them. What is the smallest denominator that everybody can divide into it, and they are just going to pick up the missing pieces? That's example number 5. And example number 6 is different kind of factoring. So let's take a look what is going to be. So if you have 1 and 1, and this is 5 and 5, because that gives you 25, you really have 7 over x plus 5 times x plus 5. And the next one is really 17 over, you can pull out a 6 times x to the third. But it's also okay to start thinking about it. What do they have in common? So in this case, I look at the 6, I look at the 30, I got the 6. I look at the x to the fourth, I look at x to the third. 3 and 4. The lowest one that means they have in common. So that's why it's 3. Because 30x to the third has 3x. 6x to the fourth have 4x. So which one has the one they both have in common? x to the third. That's why it's the smaller one in the exponent. Smaller one in the exponent. Smaller one in the exponent. So now what we're going to do is once you factor, you got to write down the rest of it. That give you x, that give you plus 5. Next line is what do they have in common? Well, you can do the long way, or you can say, hey, let's reason it out. The first fraction is missing a 6x to the third. So I'm going to multiply right here by 6x to the third. This one is also 6x to the third. But this one, the second one, under the 17, I have 6x to the third. But the one thing I'm missing from the other one is I'm missing 2 of the x plus 5. So literally, it's just finding what does each other missing, and to make it look exactly the same. What's the smaller amount that you can make each other look the same? So now what the top of the 7 over x plus 5 is going to be 42 x to the third, and the bottom is 6x to the third times x plus 5. I just want to be clear. You can write it as a second, and you can do it the second way, which is 17 times x plus 5 over 6x to the third and x plus 5. And that is how you do number 6. So please give a try example 7 and 8 and come back and check with your answers. So the answer for example number 7, denominator, is going to be 12 times y plus 2. 4y over 12 times y plus 2 and 15 over 12 times y plus 2. Number 8, the answer is 18x times x plus 1 over 2x times x minus 1 squared and x plus 1. And I am missing one of the x squared right here. So it should be, second one should be 17 over x minus 1. And the bottom is 2x times x plus 1 times x minus 1 to the second power, because they both should have 2 of them. And that concludes the notes for today. Thank you so much for watching.